Hi guys, Shouvik here. Very good morning and welcome back to our YouTube channel. Yeah, today we will solve check if a number is a sum of powers of 3. Yeah, that is quite nice question and you can expect that is a very uh, good questions in basis of you have multiple things to know, like you if your recursion is should be good enough and your math should be like you basically understand like uh, the basic power functions and how it is going to be like introduced in the time complexity of this recursive approach. Yeah, that is not a dynamic programming, that is a simple recursive approach, and with math with we can prove that is not a like exponential complexity, which is it is obviously like exponential complexity, but it is under the capacity of uh, computations limit of the system. Yeah, so let's understand the question. That is just one-liner for this question. So in this question, we are given an integer in, and we have to return like if it is possible to represent in the number that is given to us as the sum of the distinct powers of 3. So distinct powers of 3 means like uh, if 3 raised to the power x, and this 3 raised to the power, so your number should be 3 raised to the power x plus 3 raised to the power y plus 3 raised to the power z, something like this. And the major point to note is like this should be like distinct power of 3's. Like if we choose 3 raised to the power x, and then on the future we can't choose 3 raised to the power x again, so that is basically means like distinct powers of 3. So if it is not, then to so if it is not a distinct powers of 3, then to our answer should be of like all the cases it should be true. uh, because like 3 raised to the power 0, any number raised to the power 0 is 1, and if we add ups of all the ones, then we all know like one summations of 1 can be anything, summation of 1 can be anything, then the answer should be always possible. We will just add 3 raised to the power 0 to n times and we will get the number ends. So that is the like obviously answer possible, but here the main funda is like we have to choose distinct powers of 3. Yeah, and if we not able to do so, then on that case like we have to return false. And then a one-liner definitions what it is means: an integer y is a power of 3 if there exists an integer x such that y can be represented as a 3 raised to the power x. So I assume that we all know these things, like that is a very basics class 6 7 8 or some standard of maths only. Yeah, so I wrote a very standard recursive code only, and it should be very fine and very fast to give you the result on the time complexity aspects. Although it is an exponential approach, but I will prove that why it is found so. So let's understand code only today, because there is nothing to like diagrammatically represent today. So where what we have to start here is like I wrote a very standard helper functions, so which is basically start with the current value, like current sum. So I considered current sum as 0, and for every index we have few possibilities like um, we can take 3 raised to the power 0, or we can't take 3 raised to the power 0 at all. So we can take 3 raised to the power 3. I am randomly giving you an example. Or or we can't take 3 raised to the power 3 at all to our computation. So now until which we have to consider to take or not take, there should be an upper limit, right? So for that I have like check it out, so you can see like our constraint. So the constant for our question is n can be 10 to the power 7, and 3 raised to the power what can be as big as 10 to the power 7. So That is our like upper limit case. Now if I can write like 3 raised to the power 15, so you can see like 3 raised to the power 15 is somewhere bigger than 10 to the power 7. 1 2 3 4 5 6 7 kitna hai? 10 to the power 7, that is 1.4 into 10 to the power 7 something. And if I wrote 3 raised to the power 14, then that is like 4 into 1 2 3 4 5 6, that is like 4.7 into 10 to the power 6. So somewhere we figure out our upper limit should be, we have to iterate on at max 3 raised to the power 15. So that is so the n can be 1 to 10 to the power 7, and 3 raised to the power 15 should be capable enough to consider any n value. So that's the reason, like we all the cases we have trying to at max of 15 only. So this index can be grow at max 15 only, because we proved, right, because 3 raised to the power 15 is altogether greater than 10 to the power 7. So after 3 raised to the power 16 17 18 is bound to be greater than 10 to the power 7, and our constant is under the 10 to the power 7, so don't need to check for greater than of 10 to the power 15 cases. Yeah, so now the we on the recursions we have to write the base cases. So the very base case is if the current sum that we are taking throughout our helper functions, if it is matched to the provided n, then we are good. We are going to return true. And if it is exceed n value or our I value is greater than 15, so what I just told you, so if our I value is greater than 15, then we so very sure about that, or it can be like greater than equals to 15 altogether, because 3 raised to the power 15 is altogether greater than 10 to the power 7. And if it is so, then also we don't have to consider anything, we can directly return a false from here. Otherwise, we have initialized our result as a false, and we have two cases for the current I value, like 3 raised to the power what? 3 raised to the power I, 3 raised to the power I. And for that 3 raised to the power I, can we take this I to our answer? So we have two cases, can we take, or we can go without taking it. So first consider if we take it to our answer, so result can be then we will make, so we are assuming we have taken this current value. So if we have taken it, then our next helper function is going to be current plus 3 raised to the power I, because that I we are considering for which I this helper is going to be invoked. And next we are going to be considered the next 3 raised to the power x value. So x basically I here, so next 3 raised to the power I value, so I should be pointed to I plus 1. And if with this we got our answer, so we just consider when at any case our result is going to be true, then we don't have to consider any cases at all. So if our result is, we are successfully able to build by taking it, then we can directly return a true result from here. We don't have to consider not take case at all. And if it is not, then with take we are not able to build our answer. So let's try with not taking it. So if we not taking it, so our current should be current only, and without taking we just move to our next index with next x value, 3 to the power next x value. If we consider 3 raised to the power x value, then on the next iterations we have to consider 3 raised to the power x plus 1 value. So let's jump on the I plus 1 value only. And yeah, and at the end, like with not take, and just take a note, like I am doing an odd of the result, so that means like any case with take or with not take, what is the result is going to be updated. I am just returning the result from here only. Yeah, that is all about this question. And now this is an exponential complexity, because our I is moving at max of 15. So if I am check what is the value of 2 raised to the power 15, so that is somewhere like 32768, that is of 3.2 into 10 to the power 5 range. And we all know, like we can calculate in 1 second, like computer can compute of 10 to the power 8 computations. And if our function is fine enough of less than equals to 10 to the power 8, then that is like quite good solution. Yeah, by math we have proved like our solution should be capable enough to uh, under the time constraint, it should be capable enough to run it. So yeah, I am just writing the time complexity. So the time complexity for our case is what I just told, that is of 2 raised to the power 15, but again it is amortized. So amortized 2 raised to the power 15. Why amortized? Because at very max case it can be 2 raised to the power 15, because we have a function that is this one, like this 11 to 12 lane. So by taking it at for all the junctions, if we are able to build our resultant answer, then we altogether not consider not take case at all, so it is amortized. So maybe the case where we have successfully built our answer of taking only. So on this case only, like if we took 3 raised to the power 1, we took 3 raised to the power 2, and we are successfully able to build it, then on that case we are not going to explode. For like for every index we have two options: either we are exploring take options, either we not exploring not take options. So but for some of them, so let's suppose 3 raised to the power 1 is one of them, for which by taking it we are able to build the answer. So for such indexes where we are able to build the answer by taking it only, then on that case we are not exploring the not take block at all, and which is basically making our code to be a amortized fast. So that's why I wrote it like it is amortized of 10 raised to the power 2 into 10 raised to the power 5. But yeah, on interview you can explain these things and tell the interviewer, at the very worst case we are able to explore for every index take not take case. So we can't pinpoint the exact time complexity, but you can say it is at max of 2 into 10 to the power 5. And on space complexity, we are mostly not using any extra space, so you can tell either big of 1 or like or at max the recursion depth. What is the recursion depth here? So recursion depth is going to be 15 only, because we are considering our recursion tree can grow like from 0 to at max 15. So that is the recursion stack space. I can be 0 to I to the power 15. So you can tell it like recursion stack space can be big O of 15 only, so which is near about constant. Yeah, that's all about the today's question, and if you understood, so please feel to like and subscribe to our YouTube channel. And if you have any suggestions, I know I'm just going to the discuss section, so there are some solutions which is basically having some math incorporations, which is running faster on that like taking and not taking case, like recursion case. Yeah, I will explore this, and once I got a very concrete understanding of that, then I will mostly upload a video on that. And if it is not, then I would prefer like on interview, if this question is asked, then go for this only, like this is very understanding. And if you tell the interviewer why your code is quite fast on like exponential complexity, that should be like very above sufficient to make you like upper edge or clear that interview. That should be very fine. Yeah, that's all about today's video, and feel free to like put your valuable comments, and do subscribe our YouTube channel. I will put more industry standard questions to our further videos. Yeah, thank you guys, bye bye, see you.